This is part 1 of the Module 9 lecture. In the Module 9, we're going to learn to compare two parameters of two populations, the variance, the means, and the proportions. The learning objectives for this module are that by the end you should be able to distinguish between two independent populations and two related samples. Also, you should be able to identify the correct approach to compare variances or compare means, proportions from two independent populations, and then compare the mean of differences of two related samples. Once you identified what approach you need to use, then you should be able to conduct a hypothesis test to compare two variances, or compare two means, or compare two proportions from independent populations, and compare the mean of differences of two related samples. And also, on top of being able to conduct a hypothesis test, you should be able to construct the confidence interval for the difference of population means and proportions from two independent populations, and for the mean of differences of two related samples. The confidence interval for the comparisons of two variances, we're not going to cover that, but there is a confidence interval for that. It's just a little beyond the scope of that course. All right, the structure of this module is like this. So our intent is to compare the parameters of two populations. But then when you said compare, there are two possibilities. Either you're comparing two independent populations, or you are comparing the samples of two dependent samples. And we will see what that is. But as you can see, this is a flow diagram that tells you what we're going to do. So the first thing we're going to be working is with independent populations. And our very first test is going to be the comparing variances. So the numbers you see is the order in which we will cover each of these methods. So the first method we're going to look at is comparing two variances, because based on that decision, we will select the appropriate way to compare two means, either when the variances are equal or when the variances are unequal. And then, because we're working with the mean, we're going to jump to dependent samples, and then we're going to talk about comparing the mean of the difference of these two related samples to a constant value. And finally, we'll finish this module when we compare the proportions of two independent populations. And so this week we'll talk about comparing variances and comparing the means, comparing the two means of both variances and means of independent populations, but the means only for when the variances are equal. Then in the next week, we'll talk about the comparison of the means when the variances are not equal. All right, so this section, the two-sample hypothesis test, corresponds to section 10.1 in your textbook. I wanted to remind you that we're still in this procedure of the statistical analysis, where an objective has been established, that is, the target population has been identified, and the variable of interest has been identified, and its type of variable as well. Then you have define a collection plan where you define how to obtain the sample and how to evaluate each element in the sample. Then you proceed to collect the data following your collection plan. And once you have the data, you perform the analysis of the data. And that's what we're doing in these modules, analyzing the data and also interpreting the results. Because based on those results, you will draw conclusions and make recommendations for future work or decisions that need to be made. So we're in the 4th and 5th steps of a statistical analysis. And because of that, we keep on making the same assumption that the data that we are presented in each of these examples does come from a representative sample of all elements in the populations, and that the values in the samples are independent. We're making that assumption. In real life, we will have to ensure that this is done properly following our method for a statistical analysis. All right, so remember, we're making this two big assumptions, but we are not really in a practical situation. We're trying to learn the different methods of analysis. All right, so in this case, when you look at two populations, so now the problem we had when we were dealing with one population now is make it, now it's bigger. Now we're dealing with two populations. And our interest is to compare the characteristics of these two populations. But of course, we cannot sample every element in the population. So we'll take a sample from each population, and then using the statistics from each sample, we're going to make a comparison. And we're going to make that comparison on the estimates of the population parameters. All right, but this is, with this diagram, I'm just telling you that the problem starts to grow. So we have two populations, and then there is chapter 12, for example, in your textbook, deals with multiple populations. But this course does not cover that part. All right, the nice thing is that what we learn in module 7 and module 8, it will apply here. The same process to test the hypothesis will be used, exactly the same. The difference is going to be, of course, the distributions that we will use and how we define the test statistics, but everything else is pretty much the same. And of course, how the hypotheses are stated, they change a little, because now we have to deal with two parameters, not just one. All right, so when we're comparing two populations, it's very important to realize that comparing two populations implies that the same characteristic of interest is being compared, but for elements of two different populations. Here are some examples. For example, you may be comparing the systolic blood pressures of female and male patients. So you're measuring the same characteristic, the systolic blood pressure, but from elements of two different populations, male and female. Or you may be comparing the weights of similar packages filled by two machines. So now again, you're comparing the weight of this similar packages, but now they come from two origins, or two populations, of machine 1, machine 2, for example. Or you may be comparing the cholesterol concentration in the blood of patients before and after taking a medication. So these are all cases where you're comparing two populations. Now, when you're doing this, you need to make a distinction between what we call independent samples and dependent or related samples. And independent samples means that these are samples that come from independent populations. So the selection of a sample from one population does not affect the selection of the sample taken from another population. An example is the selection of female patients and male patients, and we evaluate their systolic blood pressure. So the selection of females has nothing to do with the selection of males. These are two independent populations, and therefore you end up with two independent samples. In the case of dependent or related samples, the elements in the sample are selected from one population, and their characteristic of interest is measured under different situations. In this example, we selected a patient, and we measured the blood cholesterol before and after taking the cholesterol reducing medication. But in this case, you notice are the same patients from the same population. We just evaluate them at two different stages. One before they take the medication and after they take the medication. But because they're the same individuals under two different conditions, these are why we call them related samples. All right, so I'm going to stop here, and then in the next recording, we'll start looking at comparing variances of two independent populations. I recommend that before you start this section, you print table 7. Let me see. And table 7 looks like this. It has 4 pages. So please print them all. We're going to be using them in the next section.